December 1974. A physicist at Cambridge signs a one-page bet, betting against his own theory. Across town, a radio telescope in New Mexico is locked onto a star system 7,200 light-years away that keeps flickering in X-rays like nothing anyone has ever measured. The man behind the bet insures himself against being wrong for 16 years. He will lose spectacularly, and it will take a decade of satellites, spectra, and one stubborn Canadian astronomer to prove exactly why. This is the story of how Cygnus X-1 became the first black hole science ever confirmed. Rewind 10 years. 1964. A sounding rocket lifts off from New Mexico, carrying Geiger counters instead of a warhead. It flies above the atmosphere for 6 minutes, just long enough to scan the sky for X-rays that never reach the ground. In 6 minutes, it finds something new in the constellation Cygnus. Nobody knows what it is. They just give it a name, Cygnus X-1. 7 years later, a satellite called Uhuru, the first ever built purely to map X-rays from orbit, catalogs it properly. And that's when the real puzzle starts. Cygnus X-1 isn't just bright. It's flickering, brightening, and dimming in bursts that last only milliseconds. A millisecond is 1,000th of a second. Nothing the size of a star can turn on and off that fast. Light itself can't cross a star in that time. So astronomers do the only math that works. If something changes brightness in a millisecond, light needs less than a millisecond to cross it end to end. Run the number, and the object emitting these bursts has to be smaller than 300 kilometers wide. That's not a star. That's the size of a city, Los Angeles, maybe London, flickering with the power of 10,000 suns. Here's where most people get the picture wrong. You don't just point a telescope at a black hole and see it sitting there in the dark. It emits nothing. It swallows light. It doesn't send any back. So how do you find something that, by definition, you can never directly see? You don't look for the object. You look for what it's doing to its neighbors.
I kept staring at the readouts from Uhuru, and none of it made sense for an ordinary star. Something that small, blinking that fast, it had to be compact. Degenerate matter. The question was just how compact.
And compact objects don't sit alone in space forever without giving themselves away. Because right next to Cygnus X-1, catalogued in the same patch of sky, sat a visible, ordinary supergiant star, one astronomers had already logged decades earlier, with no idea it was sitting beside a monster. That star was ordinary in every way except one. It weighed in at roughly 20 times the mass of our Sun, and it was behaving like something invisible was reaching across space and pulling material straight off its surface. Toronto, 1971. David Crampton Observatory. Astronomer Charles Bolton points a telescope at that ordinary-looking supergiant, catalogued decades earlier as HD 226868, and starts measuring something invisible. He isn't looking at the star's brightness. He's looking at its light stretched into a spectrum, splitting starlight into a barcode of colors that reveals what the star is made of and how fast it's moving. And that barcode is shifting back and forth, night after night, like clockwork. That shift has a name. Doppler shift. The same effect that makes an ambulance siren rise in pitch as it approaches and drop as it pulls away. Applied to starlight, it tells you exactly how fast something is moving toward you or away from you. HD 226868 was wobbling, back and forth, every 5.6 days, like a dance partner circling something nobody could see. In Cambridge, two other astronomers were chasing the same star. Louise Webster and Paul Murden, working independently, ran the same measurements, and landed on the same impossible number. A star's wobble tells you the mass of whatever it's orbiting. It's basic orbital mechanics, the same math that lets you weigh a planet by watching its moons. Bolton ran it. Webster and Murden ran it. Both got somewhere around 15 times the mass of the Sun. 15 suns, packed into something smaller than a city. There's a hard ceiling in physics for how much mass a dead star's core can hold before gravity wins completely. It's called the Oppenheimer-Volkoff limit, and it sits at around 3 solar masses. Beyond that, nothing, not neutrons, not any known force, can hold the collapse back. 15 was 5 times over the limit. Bolton wrote it plainly in his 1972 paper. There was no known stable object that dense. Nothing a neutron star could be. The only thing left standing was the thing general relativity had predicted but no one had ever confirmed in nature, a black hole. So by 1972, on 2 continents, working with different telescopes and different data, 2 teams had reached the exact same wall and the exact same conclusion. The numbers lined up. The physics held. Case closed, right? Not everyone was buying it.
The number said black hole. He'd spent a decade proving black holes should exist. And he still wasn't ready to call it.
It's not that the math was wrong. It's that admitting Cygnus X-1 was real meant admitting something about his own life's work he wasn't sure he wanted to be true yet.
The numbers added up perfectly. And one of the most famous physicists alive still refused to believe his own math. December 1974, Cambridge. Stephen Hawking is 32 years old, already the physicist redefining what a black hole even is. His own work says that if Cygnus X-1 is real, it should be leaking radiation into the void, evidence of something no one has ever caught red-handed. So he does something that looks absurd on paper. He bets against his own theory. The other side of the wager is Kip Thorne, an American theorist at Caltech who has spent years building the mathematical case for exactly these objects. The two men know each other well. They also know how to needle each other properly.
I bet that Cygnus X-1 does not contain a black hole.
Accepted. And I hope you lose.
That single line is the whole joke, and the whole strategy. Hawking isn't gambling for money. The stake is a subscription to Private Eye, a satirical British magazine, versus 4 issues of Penthouse, pocket change either way. What he's really ensuring is 16 years of his own emotional exposure. Hawking had spent nearly a decade building the theoretical machinery for black hole physics, including what would later be called Hawking radiation, the idea that black holes slowly leak energy and eventually evaporate. If Cygnus X-1 turned out to be nothing, at least he'd get a magazine out of the disappointment. Here's the irony nobody expected. The man who did more than almost anyone to describe what black holes should look like on paper was now betting, in public, that the first real one didn't exist. Was it caution, or was it something more personal? A scientist protecting himself from being wrong about the very thing he'd built his career on? Thorne later put it simply. Betting against himself was Hawking's insurance policy. If the black hole existed, Thorne wins, and decades of work on black hole theory get their first real trophy. If it didn't, Hawking wins, a small compensation for a life spent proving something that turned out to be fiction. The bet was signed. The paperwork went into a drawer. Quick question while we are here. Would you have spotted it? Write your answer in the comments. For the next 15 years, satellite after satellite would be launched specifically to settle arguments like this one, to strip away every remaining explanation except the one Hawking had publicly refused to accept. And the ending would arrive in a way neither man saw coming. Tokyo, 1989. A Japanese satellite called Jinga is quietly doing what Uhuru couldn't do 15 years earlier, reading the X-ray spectrum of Cygnus X-1 with enough precision to test the last surviving alternative theory. Because there was one. What if the 15 solar masses weren't a black hole at all, but 2 ordinary stars locked so tightly together they looked, from Earth, like a single flickering point? That alternative had a name, a close binary pair mimicking a compact object. It was the last honest way to explain the data without a black hole. Jinga's spectra killed it. The X-ray signature simply didn't match 2 ordinary stars orbiting each other. It matched superheated gas spiraling into something with a hard, inescapable edge. Follow-up observations through 1990 closed every remaining gap. No configuration of normal stars could produce that signal. There was nothing left to hide behind. 16 years after signing the bet, Stephen Hawking had run out of road. So he did what he'd promised. He went to Kip Thorne's office at Caltech, and without waiting for an announcement, he let himself in.
I broke into your office while you were away. I wanted the record to show I conceded before you even knew.
You put your thumbprint on the contract in front of witnesses. That's how I know it's real.
The stakes had been a joke from the start, a magazine subscription, nothing more. Hawking had promised Thorne 1 year of Private Eye if he won. Thorne had promised Hawking 4 years of Penthouse if he lost. And that was the actual problem. Kip Thorne's wife did not find it funny that her husband was now contractually obligated to receive a pornographic magazine at their house for 4 years.
You could have picked literally anything else to bet on. You picked that.
So Hawking paid the subscription against her objections, and by his own account, considered it one of the most satisfying losses of his career. He'd spent 16 years insuring himself against being wrong about his own life's work. Now he was wrong, and thrilled about it, because Cygnus X-1 proved the theory he'd built was describing something real. The bet was over. The science, in one sense, was settled too. A black hole, 15 times the sun's mass, sitting 7,200 light-years away, no longer disputed by a single serious astrophysicist. But settled that it existed is not the same as understood. Because even in 1990, nobody could say what actually happens in the last few hundred kilometers before matter disappears, the one region no equation had ever been tested against. That question would sit unanswered for another 25 years. 2015. 25 years after Hawking paid up, the Laser Interferometer Gravitational Wave Observatory detects a signal from two black holes colliding over 1 billion light-years away, the first direct measurement of gravity itself flexing space. None of it happens without Cygnus X-1. Every black hole paper since 1972 stands on the method Bolton, Webster, and Merton invented. Find a visible star, measure its wobble, calculate the mass you cannot see. Cygnus X-1 wasn't just the first confirmed black hole. It was the proof that the method itself worked. But the numbers weren't finished changing. 2021, the European Gaia spacecraft, built to map 1 billion stars with extreme precision, turns its instruments toward H-226868 and measures its parallax, the tiny shift in position used to calculate true distance. The old figure, 6,000 light-years, was wrong. The real distance is closer to 7,200. Push the star farther away, and everything orbiting it has to be recalculated too. The black hole wasn't 15 solar masses after all. It was 21. 21 times the mass of the Sun, packed into a region smaller than a city, heavier than almost every stellar black hole known at the time, and a full 40% bigger than what Bolton had calculated 50 years earlier with pencil, telescope, and stubbornness. He didn't live to update his own number. Charles Bolton died in 2021, the same year Gaia rewrote his measurement. His original estimate had stood, roughly correct, for half a century.
So what does any of this have to do with you?
Here's the connection nobody tells you. The X-ray detectors first built to study sources like Cygnus X-1 evolved into the instruments that monitor solar flares, the same flares that can knock out GPS satellites and power grids on Earth. The satellites that watch the sky for danger descend from the ones that first caught this flicker in 1964.
If you made it this far, hit subscribe and the bell. The next investigation is already in the works.
And in 2019, when the Event Horizon Telescope released the first actual image of a black hole shadow, it wasn't confirming a new idea. It was photographing something astronomers had already proven existed, by inference, 47 years earlier. Kip Thorne once put it simply, reflecting decades later on what the bet had actually meant.
Cygnus X-1 forced us to take black holes seriously as real astrophysical objects, not just solutions on a chalkboard.
We had the theory since the 1960s. We didn't have the nerve to believe it until this one star gave us no other choice.
Today, Cygnus X-1 sits catalogued, measured, and unremarkable, one black hole among the roughly 100 confirmed in our galaxy alone. But it was the first. Every mass estimate, every gravitational wave, every image of a black hole's edge traces back through it. It is still there right now, 7,200 light-years from you, still pulling gas from its companion star at roughly the same rate it was in 1964. The light you'd see tonight left before most of the astronomers in this story were born. One flicker. One bet. One bill nobody wanted to pay. That's how humanity found its first black hole.